Ever wondered how to calculate the volume of a cone? There are two main approaches to this, namely the disk method and the slicing method. We begin with the disk method. This involves approximating the cone with a series of thin, overlapping disks, each with a radius that decreases linearly from the base to the apex of the cone. The volume of each disk is calculated using the formula for the volume of a cylinder. The total volume of the cone is then obtained by summing the volumes of the individual disks. To derive the formula for the volume of a cone using the disk method, we divide our cone into thin disks with a common thickness. We calculate the area of each disk using the formula for the area of a circle. The volume of each disk is then obtained by multiplying the area by the thickness. The total volume of the cone is found by summing the volumes of all the disks. This leads us to the integral form of the volume of the cone, which simplifies to 1/3 pi r squared h, the familiar formula for the volume of a cone. Now let's shift our focus to the slicing method. This method involves dividing the cone into a series of thin triangular slices. Each slice is considered a frustum of a pyramid, which is a pyramid with the top cut off. The volume of a frustum of a pyramid can be expressed in a particular formula, where we substitute the values corresponding to a cone. This results in the same formula for the volume of a cone as the disk method, 1/3 pi r squared h. To put it in perspective, the volume of a cone is 1/3 of the volume of a cylinder with the same base and height, because a frustum of a pyramid can be considered a collection of triangular slices that are stacked together. As the number of slices increases, their volume approaches the volume of the cone. The formula 1/3 pi r squared h reflects this relationship by assigning equal portions of volume to each of the triangular slices. In summary, we have just explored two methods to derive the formula for the volume of a cone: the disk method and the slicing method. Both methods lead to the same result, which is 1/3 pi r squared h. This demonstrates the consistent beauty of mathematics, in which different approaches can lead to the same truth.